Do we have English listeners? No. Хорошо, тогда я думаю, можно...
Yes.
У нас есть в чате написали.
Okay, yes, we have. So, let's start with seminar. Does everyone has the list of problems from the course chat? Yes. Okay, so let us start. The first problem is so we say that number is y smooth if all prime factors of this number are less or equal than y. And let us denote its standard notation psi of x y. It's y smooth numbers which are less or equal than x. So, and there is a question, what's the asymptotic formula for this function? And we want to find it in particular situation. We want to find psi of x square root of x. So these are numbers such that all their prime factors are less or equal than x than square root of x. Okay, do you have any ideas how to do this? We want to find an asymptotic formula. So I advise you to look at such numbers: x minus number of smooth numbers. So what are these numbers? What can we say about numbers which we count by this formula?
So we should instead calculate the numbers which are
not smooth. Not smooth. Yes, yes. And in this situation, what can we say about these numbers which are not square root of x smooth?
These are just primes that are bigger than square root of x.
Not primes. For example, if we take a prime which is bigger than square root of x, then 2 multiplied by this prime is also not square root of x smooth.
Yes, but it will be...
It will be less than x. It can be less than x, of course.
Okay.
Okay, but
so it's going to be p times a, where a is less than square root of x.
Yes, and the idea is that there should be some prime which is bigger than square root of x, which divides our number. Yes, and the main idea is that there can be two such primes. Okay.
No more than two?
No more than one. Because if we have two distinct prime factors which are bigger than square root of x, then their product is bigger than x, and our number is less than x. Less or equal. Okay. Понятно, что?
You mean that there's no more than one prime factor?
Prime, yes, prime divisor.
Yeah, I agree, yes.
So we should, for each prime, which is between square root of x and x, yes, for each prime, how many numbers are divisible by this prime which are less than x? Who can say?
The number of such primes times square root of x.
No, we sum over such primes. And for each prime, how many numbers less than x are divisible by this prime number?
Square root of x.
No. Maybe there is
X
would-
divided
chat.
by p. X divided by p. Probably.
Yes, x divided by p integer part, yes?
Yeah.
Okay, so we have such nice expression. Is it who does not understand this equality?
Можно, пожалуйста, еще раз, вот вы тут написали p больше либо равно корень из x, а потом 2p равняется.
Ну, здесь не столь важно, да, я, наверное, так лучше написать. Это я пример писал. This is just an example, counterexample. So, here we say that здесь, давайте по-русски. Здесь мы пишем количество не корень из x гладких чисел. То есть у них есть простой делитель больше корня из x. Но у числа не может быть, которое меньше или равно x, не может быть два простых делителя больше корня из x разных. Поэтому для каждого простого вот мы просто считаем, сколько чисел меньше x на него делится. И это вот целая часть x делить на p. И суммируем по простым. И это как раз количество негладких чисел. Корень из x негладкий.
Сейчас еще раз у нас, почему это будет валидно?
Что за...
Ну да, понятно. Почему?
Okay. Are there any other questions?
Well, on the left of this equation, we might have a number which is not natural, and on the right, we always have a natural number. So
yes,
there might be some error.
That
Yeah.
x is natural.
Okay.
But the asymptotics will be, of course, the same. After we consider x to be natural, then we can extend our formula after calculations. Okay. And how to compute this? I think some of you may know, especially after the lecture. Let me remind you what's the asymptotic formula of such sum. P is less or equal than x. Who knows what the formula is?
Logarithm
ну
of
там
logarithm of x.
Logarithm will be if we sum all natural numbers less than x. Yes, this will be logarithm of x plus smaller terms. And here we have double logarithm.
Yeah.
Remember from the previous seminar, we proved that such sum is
У нас это получилось, это было лог-лог, дальше плюс константа, плюс от единицы.
А почему лог-лог p? Разве не лог-лог?
Мы сейчас на лекции, потому что получили, что сумма, что вот эта вот сумма, она раскладывается в сумму двух интегральчиков, и, значит, дальше e2 от x делить на логарифм x. e2 у нас это примерно r. Вот. И получается там плюс-минус константы. Значит, один из интегральчиков это лог-лог плюс константа, и второй у нас получился просто константа.
Now you talk about solution of this, yes?
Ну тут можно, наверное, представить это как x, деленное на p минус не целая часть, а другая. И, собственно, x делить на p, x можно будет вынести и разложить.
Let's write plus big O of 1, yes? And, okay, and what's what this will be? It will be x, yes, multiplied by square root of x less than p less or equal to x 1 over p plus what? Because of what?
One over x.
No, we
Square root of
sum
x.
because 1 over primes, and we get
Then
the number of primes, yes, because p of x. Okay.
But we only count the primes that are bigger than.
Yes, p of x
prime.
minus p square root of x, but p square root of x is
Okay.
of course this is true. Because, for example, because it's upper bound. And this will be because what? You proved some Chebyshev estimates, and you know that this is because what?
big of x.
Финальный алгоритм x.
Over
Yes.
log x.
Yes, over log x, so it's smaller than x. And what will be this sum? 1 over times
X log log x.
We use this
plus-
equation on the left.
Huh?
Well, this
Yes.
equation on the left gives us.
You should use this equation. By the way, this is Mertens' second Mertens theorem. Okay, and what we'll get? X multiplied by
X
what?
log log x plus m plus O of x over log x.
Log x, it will be we sum 1 over prime up to x, and we should
Subtract.
minus the same sum up to square root of x, and it will be what? Double logarithm of square root of x
minus m, so we can just delete m.
Yeah. Plus because 1 over logarithm square root of x, but of course it's because logarithm x. And what's now we can.
Сейчас,
Ага.
извиняюсь, а почему мы, получается, минус m сделали? У нас же,
Ну, вычитаем.
но у нас
ну,
же там до
окей.
корня из x.
Ну да. Там же тоже
Ну.
плюс m, но мы вычитаем все вот это. Окей, I make it like this.
Сейчас, а можно
Minus.
еще можно еще раз аккуратно вот тот момент с плюс-минус m? Почему у нас есть x, который мы, собственно, ну, из которого мы, точнее, у нас вот есть x, на котором это... Все, понятно.
We just make f of x
Да,
minus
все,
square root
понял,
of x.
спасибо.
I want to say that this is just a constant without this big of term. What's this constant is?
Ну там как разность логарифмов нужно.
Ну,
Logarithm of square root of x, it's logarithm x plus, oh, sorry.
там, получается, логарифм
multiply
2
by-
будет.
Yes.
By
Там
one half,
x log
of course.
2.
Yes. Logarithm 2 plus because of x over log x. It's from these terms. And we see that x minus c of x square root of x is x logarithm 2 plus big O of x over logarithm x. And this is asymptotic formula. Okay. Yes, and we wanted to find psi x square root of x. And let me write it in such way. It is asymptotically equal to what? X
Ну,
1 minus logarithm 2. Yes. Asymptotically equal means that if we divide first part by second, then its limit is 1.
Yeah.
Yeah, and this problem has we can say more that if we take c of x u root of x, and if we divide it by x, so this is generalization, then this has a limit if x tends to infinity. So in our case, we proved this for u is equal 1/2, 1/2. And it has a limit, which is called Dickman function. Its function of argument is u. And so we showed here that rho Dickman function, that rho of 2 is 1 minus logarithm 2. And it's interesting story with Dickman function about smooth numbers. Okay. So let us skip problem 2, not because it's hard, but because it has many details. We will return if we have time. By the way, with Zoom is not, I don't pay for Zoom, so in 10 minutes, I will send you another link, okay? Another conference. Problem number 3.
А почему вы второй пропустили?
I just said that it is a bit long. I want to solve problem 4. Problem 2 is about previous seminar. I will tell maybe some words at the end how to solve it. A hint. Maybe we will solve it together. So problem number 3. Greatest prime factor of n. We denote GPF of n. And we want to find the order of magnitude of such sum. N less or equal than x, greatest prime factor of n.
What is the order of magnitude?
Yes, and it's different from asymptotic formula. We do know what this sign means. And if we write that f.
Ну, это когда f равняется O большое от g, и g равняется O большое от f.
Yes, and we want to find some nice function such that this is equal this function in both ways. This will say that it's order of magnitude. Okay. Do you have any ideas?
Maybe task 1 could be useful.
What can be useful?
The first task.
The first task.
The first problem.
Maybe it can. Maybe not. You mean write it in terms of smooth numbers, but we don't know a lot about smooth numbers. We know it in particular situation. Okay, so let's rewrite it a bit. This big P means that it's the largest prime factor. Okay, so it's this is trivial reformulation, and I want to say that yes, it's maybe the idea is connected with problem 1, that such set, I mean this set, is a very clear set when P is large. What's this in this situation?
Well, in case P is greater than square root of X, it's X over P integer part.
Yes. Okay, and let's just...
What's capital P of n? What is capital P of n?
It's the largest prime factor of n. I'm not sure how standard this notation is, but in many cases, let me write it. P of n.
I thought largest prime factor of n is GPF of n.
Oh, yes. Of course. Yes, it's just my notation, which I'm used to. GPF of n is P. Okay.
А можно еще раз вот этот переход, чтобы мне объяснить?
Yes, for primes which are larger than square root of x, what does it mean that the greatest prime factor of n is p? It means just that they are divisible by p, because if they are divisible, they cannot be divisible by any other prime greater than p, because in this case n is bigger than x. It cannot be divided by two numbers greater than square root of x, distinct numbers. Okay?
Да, спасибо.
Number of, and plus, let's write it like a residual term. We have sum over primes less than square root of x of what? P multiplied by I think x will be enough. Of course, there are no so just x, okay? Okay. And now you...
So the first summand here is for the case when P, the largest prime factor is between square root of x and x, right? And the second summand is for the case if otherwise.
The rest, and of course there are no bigger than x numbers which are divisible by any prime.
Okay.
Okay, and as you see here, so this is because of such sum, yes, square root of x p, yes, because plus sum of square root of x px, p multiplied by x over p, so it's just x. Okay, and as you see, we should know something about such sum. Sum over primes, p is less or equal than y.
Так, извиняюсь, у нас осталось 2,5 минуты. Вот. Да, просто про новую ссылку напоминаю.
Yeah, I'll try to do it in 1 or 2 minutes. Nearly.
Thanks.
Yeah, what can we say about such sum? Do you have any ideas? Which some upper and lower bounds in terms of bigger? Yes. Big of what?
It's denoted by pi of y, doesn't it? Oh no, it isn't. No. It's the wrong thing.
Pi of I is the number of primes, and here is the sum of primes.
Yeah, right.
And what can we say about?
Well, it's obviously denoted by y multiplied by pi of y.
Yes, it's less than y multiplied by pi of y. Yes, if we change each y to to I, and this is y squared divided by a logarithm of y. Yes, and I want to say that we can give the same lower bound. Because, yes, we have less than 1 min, but okay, let's move to another conference. Okay, see you.
Yeah, the lower bound is pi of y, right?
No, it's the same. It's okay. Think about why it's the same bound. Okay, I'll try to make another link. Let's continue. And the problem was to find such sum, greatest prime factor n, and we rewrite it as sum of primes between square root of x and x. Plus because of sum of primes less than square root of x multiplied by x. And to understand something about such sums, we want an asymptotic for sum of primes less than y. And as we understood, it is less than y squared divided by logarithm of y. And I want to say that the lower bound is the same, just the constant is different. So let's you proved some upper and lower bounds for number of primes. Yes, I think certainly you should know something like this. Divided by, for example, by 3. I think it should be enough. It's bigger than x over log x. Do you know such? Can you prove such bound from lecture?
Ну, кажется, это просто берется, записывается в таком виде. Нет, там проблемы возникают.
Okay, I think you know that p of x is less than x over log x, yes? And
it's in fact equivalent to x.
Yes, in fact, but you didn't prove it on lecture because it's a hard theorem. What you proved is such bounds, yes?
Сейчас, а у нас там вот слева логарифм, ну, x делить на log x.
Yes, it's the same. Upper and lower bound. And here are some constants. So at least you know that for some big N, this is bigger than x over log x, yes? And this N depends on what are your bounds. Better they are, less N you can make. Actually, you can N can be any number bigger than 1. But we don't know how to do it. And so I want to say that we can write this as this is less or equal than P we can write from y divided by n, yes. N is fixed, yes. It depends on our bounds, which constants we have here in this signs. P from y over n up to y. And here we sum y over n, okay? And this is bigger than from these bounds I squared divided by logarithm of I. Okay?
Можно этот момент поподробнее?
Ну, мы смотрим, давайте смотреть только на простые, которые больше, чем y делить на n.
Да,
Ну, тогда простой мы снизу можем оценить y делить на n.
да,
Ну и
понятно.
умножить
Не,
на их
меня
количество.
скорее вот последняя оценка, именно то, что больше, чем y квадрат делить на log.
Ага, ну мы y делить на n
Мгм.
умножаем на π от y.
Да, все понятно.
И от y делить на n. Ну, what n, here I wanted to make n to be free. Or maybe you can make it to be 2 from actually. I think it's possible. Okay. So we know the order of such sum. And from here we know that this is less than what? We need upper bound. Here we have, here, what is this? This is square root of x square. So it's x multiplied by x and divided by logarithm of square root of x. It's the same as the logarithm of x. Yes. And what we have here?
Сейчас, вот эта сумма у нас, точнее, как О у нас меньше либо ну,
Yes, it's big
всё.
O. Yes, it's equal to, this is big O of x squared over log x. And I think that the same is for this, because upper bound for each summand is x, and we sum it over primes up to x. And it is p of x multiplied by x. And again, it is x squared over log x. Okay?
There's probably x cube, because from the sum
No.
we get x squared, and then we multiply it by x also.
Where x squared? Here is square root of x, so it's square root of x squared.
Yeah, right, yes.
Okay, and what is the lower bound? Actually, this term is big O, but it is positive, this one, because it just terms corresponding to primes which are less than square root of x. But of course, we can count over primes which are bigger than square root of x. So this is less that such sum. And such sum, what is it? For example, I think you can use such identity that a is, of course, it is less than a divided by 2 if a is bigger or equal than 1. Yes? Here's, okay, I'll write it in this way.
Сейчас еще раз, можете повторить, пожалуйста? Вот просто не очень различаю почерк. Получается, А у нас примерно как целая часть А.
Не примерно, а она у большой от целой части А.
Мгм.
При А больше равно единице.
Сейчас. Все, понятно.
Ну, при А меньше единицы, тут справа 0, ничего не получается. So it is less than, here we can just write x over p. And it will give us x sum over square root of x up to p up to x p. And we know lower bound. It's yes, sorry. Here is 1. Yes. Okay, here is 1. And it is less than x p of x. And it gives us the same order. Huh? Are there any questions about this problem? Okay, so maybe we should move.
Можно один только вопрос?
В
самом начале, вот когда мы представили вот эту сумму GPF от n, там первые слагаемые понятно, а как мы, собственно, получили O большое от суммы PX?
For each prime, we multiply this prime by the number of numbers which are less than x and greatest prime factor of which is p. Yes. So there was a formula, something like that: sum over p less than x, p multiplied by n less than x, such that greatest prime factor of n is p. Yes. And I just said that, of course, this is less or equal than x. And here it is written. We just change every such set, number of elements such set in x. And it gives us upper bound.
Я понял, спасибо.
So we proved that the first summand is bigger than x squared divided by log x, and we proved that the second summand is less than x squared divided by log x.
I said that this summand is positive. It's just such sum over primes which are less than square root of x, and it is positive. So if we give lower bound for such sum, we can give just lower bound for this term, because this is positive. It turns out to be positive.
So we just need to find the lower bound for the first term, and
yes, and it turns out to be the same lower bound. So we proved that this is x squared over log x. And it turns out that actually it is asymptotically equal to some constant multiplied by x squared over log x, but of course it's harder to prove. Okay, are there any other questions? Okay, I think problem 4 is maybe the most interesting. Here, find an asymptotic formula for sum omega of n. It's number of distinct prime factor. Let me write omega of p1 alpha 1 pk alpha k, just k. Okay, and big omega of the same is sum of powers. So it's number of prime factors with multiplicity. And we want to find average order of such sum. I think someone can do this problem. It's not hard. So what's this by definition? It's sum over n less or equal than x of what? I want to write omega of n in like a sum of the primes. And then change the order of summation like we did in the first seminar. Anyone? I want to say that this is sum of the primes which divide n. Okay. Does anyone hear me? Maybe my sound is off.
I hear you. I just.
Okay, and here we can change the order of summation. What we will have?
Получается, сейчас вторая сумма, вот которая внутренняя, она у нас, по сути, считает просто все простые делители числа n.
Да.
И мы это для всех n, чем заданные x.
Ну да. Ну, как это переписать?
Sum by all p less than equal to x.
And here?
The sum by all n, well, p times.
Yes?
Yeah.
And what's this?
All n that are multiples of p.
And less than x. How many such numbers were?
X divided by p.
But not only this, but integer part, yes?
Yeah.
And I think we can find an asymptotic formula for this from the previous information from lecture, etc. Is
We should probably again split it into integer part.
No. Yes. Plus x over p plus what?
The
Equal what?
of 1.
Okay, of sum of primes less than x. Yes.
Of 1, yeah.
No. Yes. Because it's like. And here what we have? X sum over primes less than x 1 over p plus what? Because what?
Pi of x.
Yes, pi of x, and it is x over log x. We know it from Chebyshev estimates. And this sum we also know formula for this sum.
It's logarithm of logarithm of.
So it's x logarithm, double logarithm of x, plus some constant. Yes, x, it will be x multiplied by some constant m. It's called Mertens constant. Plus this term. But actually, for this exercise, let us write bco of x. Okay. We can write second term in asymptotic formula, but this will be enough for our purpose. Okay, is it clear this formula? And sorry, I can't hear you. maybe.
После того, как мы поменяли значит суммирования, у нас там вот равно сумма целой части x делить на p. Вот можно еще раз, пожалуйста?
I want to say that x over p integer part is just x over p plus big O of 1.
Не, чуть-чуть раньше. Вот мы поменяли, значит, пределы суммирования вот тут, да. Вот это следующее равенство. Почему мы
здесь?
перешли к сумме p меньше x, меньше либо равно x целый p?
Вот это равенство.
Да, вот тут вопрос.
Ага, потому что для каждого p, вот здесь что мы считаем? Мы считаем количество n, которое не превосходит x и делится на p, да? Я отдельно напишу. I'll write it separately. We count the number of n less than x such that they are divisible by p. And what's this? It's number of solutions p multiplied by a is less or equal than x. Wow. Yes. How many such a there are? A should be less or equal than x over p. And how many integers such that there are less or equal than x over p? Just x over p.
Да, понял, спасибо большое.
Mm-hmm. Okay, and what will be the same story with big omega? How we compute this? It's pretty the same, but now we sum not only over primes, but also over powers of primes, yes? Understand this formula?
Yeah.
Mm-hmm. Okay. And now it's just sum of powers of primes x over p to the power k. And now I want to say that it's just the same. It will be you see powers which are bigger than 1 they give big O of x. Does anyone understand why? I want to say that this is sum over p less or equal than x, x over p, yes? And it's the same sum as we had, plus big O of x. Do you understand why here is big O of x? Why all powers which are bigger than 1 gives big O of x?
Well, maybe because there are something like, можно на русском? Смотрите, просто у нас вот те члены, которые были для старших степеней, то есть для p квадрата и так далее, они примерно как O от корня соответствующей степени. Ну и дальше у меня есть подозрение, что вот это суммирование нам даст как раз-таки O от x.
Да, ну, можно так сказать. I can say it in such way. This is big O of sum over k, in our case, is bigger than 1. And I want to sum over all primes, not just I drop this condition. And here I write x over p to the power k, yes? And I want to say that this is big O of x because sum over all powers, not only prime powers, it converges. Okay, converges to what? Who knows what is this sum? It doesn't matter. Let's write big O of 1, but it's a good rational number, actually, natural number. So this is big O of x, yes? Is it clear? And now we, yes, and now we write it x log x, just like in this case, plus big O of x. So we again found the same asymptotic formula. Okay. Are there any questions about 4a? Not, we switch to 4b. And here we want to find such sum omega of n square, no square, n less or equal than x. Asymptotic formula for this. Okay, maybe someone can start to write what should be next. Let's just do the same as in previous case. This is sum over n.
But then let's add the square to the
yes.
inner sum.
When omega of, not omega, 1 square. Yes. And here we have, if we open brackets, we will have a sum over pairs of primes, yes? So there will be sum which corresponds to when we take a pair and first and second prime are the same prime. Plus sum over n less than or equal than x, sum over pairs of prime which are different. Actually, let me write it like sum over all primes, okay? It doesn't matter. PQ divides n, okay, 1. Plus, minus, well, we have now 10 minutes, minus sum over n less than x, sum over primes, p squared divides n, okay? I want to say that these sums, they are it will be small comparing to the main term. Okay, is this formula clear?
Yeah, the formula is clear, but what comes after it? They're gonna be...
Можно все-таки пояснение, откуда у нас самый первый взялся?
Yes, we open
Самый первый.
brackets here, and we have one square. So if you have sum over AI square, it will be sum over AJ. I is not equal to J, plus sum over AI square. And here AI is 1, and we get...
Да, и вот как раз вопрос, откуда именно первый взялся, потому что, мне кажется, это вот такие вот лишние пары убили тем, что из второго вычли третий.
Here is p square. I just didn't want to write it, to write p is not equal to q. It doesn't matter. These are very small comparing with this
Но
term.
там вопрос скорее именно, почему у нас вот откуда взялось первое слагаемое, которое у нас просто p делит n.
Ну, отсюда. Просто 1 в квадрате переехал вот внутрь.
Не, у нас... Сейчас. У нас просто получается, что мы по факту берем все попарные суммы по простым делящим n. Вот. То есть это мы второй член взяли. Но те, которые у нас совпадающие, мы взяли 2 раза. И мы их вычли вот в третьем слагаемом.
Ну,
То есть откуда у нас...
я
Да,
могу написать здесь p не равно q, а это стерео, правда?
да,
А я, если добавлю условие p равно q, у меня здесь pq будет p в квадрате.
да, я
И
понимаю.
это
Вот
разные
как раз таки я отсюда пытаюсь понять, а не эквивалентно ли, точнее как, вот какому условию отвечает самый первый член в этой сумме? То есть который сумма по p, делящим n.
Да, ну просто когда у нас p равно q, это не значит, что p на q, то есть p в квадрате делит n. Это значит, что p делит n. Вот.
Все, понял.
Это просто для симметричности дела, это не обязательно.
Понял, спасибо.
Okay, let us compute the main term, and I think this remainder term you can estimate by yourself. Okay, what's this main term? I think here it will be useful to use Dirichlet hyperbola method. You know, I think you know something about it from lecture, yes? Okay. What's this sum? It
Ну,
is...
самый первый член этой суммы мы только что посчитали.
It's sum over pq less or equal than x. Yes. Let me write it in such way. P multiplied by q is less or equal than x. X over pq. Yes. For each fixed pair p and q, we have such number of n's which are divisible by their product. So we want to compute. We want to compute. This is what? Because of pi of x squared, yes. Plus x multiplied by pq less or equal than x 1 over pq. Okay.
А p от x квадрат взялось как раз-таки из пар, которые p равно q.
This you mean?
Да.
I did the same as in previous. I write it integer part as x over pq plus bq of 1. And how many bq of 1s? It just, this is upper estimate, of course, p of x square.
Once again, please. Сейчас. Можете на русском еще раз повторить просто?
Да, ну.
То есть мы, получается, записали это как x делить на pq плюс o от единицы.
Да.
И откуда у нас...
O
и у
от
нас просто
единицы,
получилось...
а сколько от единиц? Ну,
Да, все понятно. Спасибо.
Okay. Now we want to find such sum. I want to say that sum over pq less or equal than x, 1 over pq is is double logarithm of x square plus big O of double logarithm x. Maybe there are some other ways to prove it, but I can do it using Dirichlet hyperbola method. So we have such picture. We have here will be A, B, and we have hyperbola. AB is less equal than x, and we want to sum 1 over AB over integer points which coordinates are primes. Yes, 1 over B, AB. And I want to say that we have symmetry. We can sum up to square root of x. So we can sum in this over this area. Okay, then for example, then p is less than square root of x. After that, we sum with we double this sum, and because of the symmetry, we will get such sum over such area. Yes, and after that we should make minus this area sum over this area over this square. Okay, so this is essentially the idea of Dirichlet hyperbola methods. Okay, we have 1 minute and I think 13 minutes, yes, of a seminar. So I think the same link should work. Okay, we will finish problem 4, I hope. Okay, see you. See you soon. The same link. We write it our sum in such way. We said that omega of n square is x sum over pq less than x 1 over pq plus actually there were some other terms, but you easily can prove that they are the core of x log x. And what we want to see that this is actually the main term is square of double logarithm of x. And if we prove it, we will find the asymptotic formula. PQ less than or equal than X, 1 over PQ. And I...
Извиняюсь, у нас же там еще была, во-первых, сумма вот этих вот W от N, ну, точнее, омега от N из пункта А. И еще была, ну, у нас же, ну, короче, у нас оно имело вид, значит, сумма по n меньше либо равным x. Дальше сумма единиц по p делящим n.
Да, в смысле, было еще два члена.
Да, два слагаемых, куда они делись?
Да, я сказал, что вы их можете вот так оценить, проверьте сами. Okay? I said that, of course, there were two other summonds. I say that they are because of this. Please prove it. It's not hard. And we want to...
We already proved it, in fact, I think.
Yes, but check it. And here I wanted to use Dirichlet hyperbola method. I said that here we sum over integer points under hyperbola. Yes? And have you seen this picture on the lecture?
Nope, we did not have this picture on the lecture.
Okay, and here is geometric intuition of Dirichlet formula. So you used this to find I think you used this to find the average order of tau function, yes, and less than or equal than x. And here, these are just integer points or under this hyperbola. And the idea was to sum over, to find the number of integer points in this area. Here is square root of x, yes? Multiply by 2, and because of you have symmetry, you will find a number of integer points over this area. And after that, you should make minus points in this area, and it's easy to find it. Just integer part of square root of x square. Yes, this was the idea, to find asymptotic formula for this. And here is the same, but with some not 1 over this integer point, but 1 over a multiplied by b. So this will be sum over this area is prime 2 multiplied by sum over primes which are less or equal than square root of x, yes. And here you sum q over primes q. Here will be 1 over p. And here will be sum over q less than what? Than x over p, yes. Q1 over q. Multiply by 2, we have sum over these two areas minus sum over square. Sum over square is just the sum over p is less than square root of x, q is less than square root, less or equal, doesn't matter, it's small error. 1 over pq, yes? Okay, what's this? The first sum. You see here, q is prime with sum over primes, and it will be double logarithm. Yes? So let me write it. On my notes, 2 sum over p less than square root of x, 1 over p, double logarithm of x over p plus m plus big O of 1 over logarithm x over p, but it's big O of logarithm x because p is less than square root of x. Yes, something like that. It's the first term. Okay, here we used our theorem, Lorentz theorem. Minus, and here just a square. It will be square. Okay. Is this clear? I just subtracted with our formula for sum over 1 over sum 1 over t over primes. Okay?
Yeah.
Yes, and if you look carefully, for example, yes, you see, I think here the main term is log x square. Plus bq of log x. Because p is less than square root of x. So log x over p. For example, we have.
А куда у нас m пропало?
M here you see we sum over p less than square root of x 1 over p multiplied by n. It's bq of double logarithm of x.
Understood.
Yes.
Thanks.
And here 2 also we have 2. And you should deal with this sum, but as I said, it's difference with log x. It's bq of 1, and if you sum bq of 1 over p, you again have bq of log x. Minus, and here of course this is log x square again plus bq of log x. Yes, and here we have 2 minus 1, we get log x square plus bq of log x. And okay, is it clear? We have just several minutes, and I want to say what we have done in these problems. Are there any questions? So you can do the same for becoming of n, and the answer will be the same. And let us consider small omega of n like to be a random variable. So let us think about it as a random variable which takes value from 1 to x. X is an integer, and each integer value takes with the same probability, 1 over x. Yes. And what we've proved is that the expected value of omega is what? Expected value of omega is sum over n, omega of n, divided by x. Yes, we proved that this is log x plus error term. I would not write it. Okay. And we proved that, and what's the expected value of square of omega? It is square root of double logarithm x plus this term. Here is becoming of 1, here is becoming of double logarithm of x. And what's the distribution of omega? You know that it is expected value of square of omega minus square of expected value, yes?
Not the distribution, you mean the dispersion, or how is it?
Oh, yes, dispersion, sorry, yes, of course. And this will be before of log x, because here you have
It's variance, yes.
yeah,
It's not dispersion, yeah, it's variance.
Yeah, variance, yeah, okay, yes.
Sorry.
Double sorry. Variance, and you see this square of double logarithm, it cancels. Yes, here, because here we have square of double logarithm minus again square of double logarithm. And it gives us such estimate. And actually, Erdős-Katz theorem tells us that with omega, the variance is actually double logarithm. And also it tends to normal distribution, and this is the big Erdős-Katz theorem. The next problem, C, what it tells us, to estimate n such that tau of n are away from average, that there are not a lot. And here you can write such trivial estimates. Okay, I give you a hint because we have no time to solve this problem. There are such trivial estimates. Think why this is true. And after that, you want to show that there are not many numbers such that tau of n is not normal. And actually just use the Chebyshev inequality. Do you know Chebyshev inequality from random theory? Probability theory.
I remember a theorem like this.
Yeah. And you have an upper bound for variance, yes? And
yes.
So Chebyshev theory inequality gives you upper bound for probability that element is far away from its average. And here it will give you a solution. And okay, so try to do it by your own. Okay, I think the seminar we ran out of time. Do you have any questions? Okay, thank you. Goodbye.
Thank you. Goodbye.
Thank you.